here's sort of a summary of where students should be at this point. Um, they should understand what classic experiment design is and understand, the essential question defines the independent variable that you want to change. You want to understand the role of that variable in what you're studying. They should understand that you might want to understand the role of gravity in something. That's what drives all experiment design with SSEP. And so you need to change the gravity variable and see what happens. And they can understand that if you go to a weightless environment like where the astronauts are, gravity appears not to exist. So if you bring your experiment to that weightless environment, it will behave as if there's no gravity. And if you run an experiment on the ground, the control at the same time, this is operating in gravity. So when you bring your flight experiment down, you put them side by side, that's what a microgravity experiment is. You're looking at behavioral differences in what you're studying. Now, if you want to go into the deeper level, because you want them to understand why the astronauts are weightless, well, you got to take them to the top of the Empire State Building. You got to show them that the elevator in free fall inside, everything behaves as if gravity's turned completely off. You might want to start taking them to the top of a mountain 47 times higher than Mount Everest and show that they're not far from the Earth at all. So gravity is alive and well in space, okay? And then you might want to show them the ping pong ball stuff. All of that's on the website. If you want to go into that depth to understand why the astronauts are weightless, you can. If you don't want to go there and you just want to state as a principle that gravity exists in space, but the astronauts are in a freely falling environment, whatever that means, that's why they're weightless, you can go right to a microgravity experiment. Everybody with me on that? So now the students say, okay, we are ready to design our microgravity experiment. But wait, how do we even start coming up with an experiment in microgravity? Well, I'll give you 5 separate ways that students can come up with a microgravity experiment. The first thing is to reiterate what I said earlier, which is the first thing they need to do is read the mini laboratory operations page that has all of the engineering and technology constraints on what can be done in the mini lab and what cannot be done in the mini lab. And only then do you start figuring out what your science experiment is. So for instance, one thing that you cannot fly is technology, which, so no mechanical systems, no electrical systems. Flight safety review for that takes years. So it's only fluids and solids. And so if you want to fly like, a laser system, I'm sorry, not only is that technology, but it's not going to fit in the mini lab. So you need to know the mini lab operations page backwards and forwards. So one of 5 ways that students can come up with a microgravity experiment is they can read that page, look around their world, and say, I wonder what the role of gravity is in that, and I know that that can work in the mini lab. So I'll give you 2 examples. There was a middle school young lady who went down into her basement one day. It was very damp down there. She saw moss growing on an inside surface, and she said, I wonder what the role of gravity is in the life cycle of moss, and I know that that'll work in the mini lab. Another young lady was a junior in high school, and she loved biology the year before. And there was a laboratory that she really got jazzed about. It was the planaria worm regeneration lab. Oh, that must sound familiar to you. And so she said, I wonder what the role of gravity is in planaria worm regeneration. And I know that that can work in the mini lab. So the first way of 5 that students can come up with is an experiment. Look around your world and say, what's the role of gravity in that? Everybody on board with that idea? Okay. The next possibility is you can do research online and see what kind of microgravity experiments have already been done in space, get ideas. A third way to do it is you can go to the document library and download the microgravity science background document, which has an overview of 9 separate science disciplines appropriate for microgravity research and why, like crystal growth. And there's an accompanying case studies document that has examples of experiments in each of those 9 science disciplines. So that's the third way you can get ideas for a microgravity experiment. A fourth way to do it is to download the experiment samples document in the document library, which lists hundreds of fluids and solids that are appropriate for microgravity research, that are used all the time in microgravity research. That's another way to get an idea. And the fifth way to do it is you can go to the SSEP website and read a one-paragraph summary of over 400 SSEP experiments already done in the mini laboratory in different disciplines. And there's a page dedicated just to undergraduate participation, so you can read about all of the undergraduate experiments that have been done. And if a student team wants to do one of those experiments over again, they can. Or if they want to do one of those experiments a little differently, they can. Now you might say, isn't that cheating to read somebody else's experiment and do it over again? No, and I'll tell you why. The first thing is, we're not expecting students to add to the human book of knowledge. We're not expecting students to do something wholly new to the human race. We're immersing them in real experiment design constrained by real world engineering and technology constraints, and going through a proposal review competition. Now, the second important point is that the deliverable from those students to the instructors, to the faculty, is a formal proposal. That's their work product. And what does that mean? It's written against a proposal guide. And in the first section, it has to just explain what experiment is being proposed and the essential question driving that experiment. They have to provide a justification for why it's a good microgravity experiment, with citations in the text and a bibliography of primary references. They have to provide a procedure area section, which talks about how the experiment is going to be done in space, how it's going to be done on the ground. And there's got to be an analysis section. Well, how are you going to analyze, how are you going to compare the ground control and the flight experiment to see if you've come up with an answer to the original question? So an analysis protocol. And you cannot get that from a one-paragraph summary on the website. You just can't. And there are no proposals anywhere on the website. Now, the community program directors got a program start email with exemplars of selected flight experiment proposals, so instructors can get to see what a flight experiment proposal looks like. But you cannot and must not share those proposals with any students, which is in bold lettering on that program start email, because students will be given a roadmap if you give them the proposals. They have to come up with the proposals from scratch. So does everybody understand the 5 ways that you can get students noodling about experiment design? Anybody have any questions on that?